The astronauts read out
the gravitational effect of those planets.
Hey, I'm Kristen, and this is NASA Now.
When we first got to Mars, we found a planet that was basically dead.
Today, we know that Mars is anything but dead. We'll talk with an expert who will tell us how curiosity is driving the next phase of exploration on Mars. That's ahead. First, here's what's happening at NASA Now. NASA's Mars Reconnaissance Orbiter has made a stunning discovery. Based on data and imagery from the MRO, scientists believe there may be water flowing on the planet's surface. The announcement was based upon dark finger-like lines that appeared to widen and darken on some of the Martian slopes through late spring and summer. Scientists think this could be a liquid which contains high concentrations of salt, also known as brine. If this is true, it brings us even closer to determining whether the red planet could harbor life in some form. Now, let's take a look at the past.
July 14, 1965, history was made when Mariner 4 passed within 6,118 miles of the surface of Mars and sent back the first close-up images of the red planet.
The mysterious red planet Mars has fascinated people for centuries. So why are we so interested in the fourth planet from the Sun? To give us a better picture of past and current exploration of this Earth-like planet, we're visiting with Nagin Cox at NASA Jet Propulsion Laboratory in Pasadena, California. So Nagin, tell us why NASA wants to go to Mars.
Well, the theme of solar system exploration, whether it's Mars or somewhere else in the solar system, has been follow the water. Water is essential to life as we know it on the Earth. So is there life, is there water somewhere else in the solar system? That was the main goal of Spirit and Opportunity, the two Mars exploration rovers that landed in 2004, and Opportunity is actually still operating. Their goal was to find out, was there ever liquid water on Mars in the past? And the answer to that was yes, there is. Mission accomplished.
So how is Curiosity or Mars Science Laboratory going to pick up where Spirit and Opportunity left off?
The Mars Science Laboratory is like a robotic chemist. We're actually taking instruments this time to try to find out what the rocks were like, what the chemistry was like. Is it possible that there were ever organic molecules? The building blocks of life. So these missions build on what the prior mission did. And all along the path of trying to find out, is there somewhere else in the solar system that once could have harbored life as we know it?
We know Curiosity is bigger than the other rovers. How do you land it safely?
The approach that Mars Science Laboratory is taking is first, we use the same method of slowing down through the atmosphere using a heat shield and then a parachute. But then at that point, the rover actually drops out of the back shell in something that looks a little bit like a jetpack on its back. So the rover kind of has a jetpack on its back. Then we use the jetpack to fly closer to the surface. And then once we're at a certain height above the surface, the jetpack hovers, kind of turns into a helicopter, and then lowers the rover on a bridle, a tether, until we get right to the surface. And while the rover is lowering, the wheels are deploying. So it's a very exciting and complicated set of things we have to do to get the rover to the surface. But once we touch down, the rover is on all its wheels and basically ready to start its mission.
So how does a mission like this happen?
Well, like many great ideas, it starts just as that, as an idea. So usually we get an idea of what our scientific goal is, and then that is put forward to NASA and the scientific community, often as a proposal for what we'd like to do. So once the idea has been selected as a good thing to use money to do, to try to answer this scientific question, then it becomes a real mission, one that we can start to design and build hardware.
How long does this process normally take?
That process, when it's going really quickly, can take about 3 years. But in general, it's about 5 to 7 to even 10 years to develop a mission to Mars to the point where we have hardware built, where it's been tested, and where the teams have been trained and are ready to go.
Wow, that's pretty cool. What's your hope for the future of Mars exploration?
My hope is that we will continue to explore space robotically and with humans, and that we will do it peacefully and together as one world.
Do you know why Mars looks red? It turns out that the surface of Mars contains iron-rich minerals, which are essentially rust or oxidation. When this rusty dust of Mars gets stirred up by storms on the planet's surface, it gives the atmosphere a reddish hue. Now you know.
Now it's time to check out what's up.
Depending on the position of the planets in their orbits, the distance between Earth and Mars varies from 54 million kilometers to as much as 400 million kilometers. This means that at the speed of light, a signal from Earth can take anywhere from 8 to 18 minutes to travel the distance.
A big part of space exploration is imagining what the future may hold. Will people live in space or vacation on another planet? NASA wants to know what you think with the Space Settlement Contest.
Here's a great opportunity for you and your classmates to join the ranks of top scientists in designing and creating plans for the ultimate space destination. To enter the contest, click on the link on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to tune in next time to learn how lasers detect pollution in our air. We'll see you then on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.